Okay, today we are looking at how to find the standard deviation. So you can see there is a question on the board. The frequency table below shows the mark distribution for 30 learners in a math test. Calculate the standard deviation, 6 marks. So this is the question, and this is the information that has been given on this question. This is the information that has been given on the question. We have the marks given in set builder notation. We also have the number of learners, which is also the frequency. So we have the frequency for each one of the intervals there. You can see when we add all the frequencies, 2 plus 3 plus 3 plus 5 plus 6, 6, 3, 2, we are getting 30. So for us to be able to get the standard deviation, we have the formula. SD is equal to the sum of fx squared over the sum of f minus the mean square. So this is the formula that we are going to use. So in the formula for standard deviation, there is the mean. So we need first to get the mean. After getting the mean, then we shall use it in the formula. We need also to get sigma fx square and also sigma fx to get the mean. So let us set the ball rolling. Okay. So we have to get the midpoint for each one of the intervals. You can see our first interval is 10 less than x less or equal to 15. This is set builder notation, which tells us that the first number 10 is not part of the interval because we have less than a. So the first number 10 is not part of the interval. So this interval is scattering for the numbers 11, 12, 13, 14, and 15. So it is scattering for 5 numbers. So we need to find the midpoint of this class. So the midpoint of this class, you can see 11, 12, 13, 14, 15. The midpoint should be the number between all those measures that this class is scattering, which is 13. So our midpoint here is 13. And when we do the same for the next class, we shall find our midpoint will be 18. Then we shall have 23 and 28, 33, 38, 43, and 48. So these are the midpoints of each one of the classes that we are looking at. So now when we have now to get fx, meaning that we multiply for each one of the intervals, we multiply the frequency and the midpoint. So we start multiplying. We have what? We have 26, and here we have 54, and here we have 69, then we have 140, then 198, and 228, 129, and 96. Okay, so these are the f-axis after multiplying each one of the frequency for each class, frequency, midpoint, frequency, we are getting that one. Then we get fx square. Fx square, we square this one, we square the midpoint, then we multiply by the frequency. Square the midpoint, multiply by the frequency. So when we square 13, multiply by 2, square 13, multiply by 2, we are getting 338. Here 972, and here 1587, 3920, 65, 34, 86, 64, 55, 47, and 4608. Okay, so these are the fx squared. These are the fx squared gotten after multiplying, after squaring the midpoint. We square the midpoint, then multiply by the frequency, midpoint square, frequency, square midpoint, frequency. So this is what we are getting. So now, let's now sum the fx squares. When we sum these, the fx squares, when we sum them, we are getting 32,170. We are getting 32,170. That's when we square these. We are getting 32,170. And when we square the f-axis, we are getting 940. When we square the f-axis, 26 plus 54, when we add these, we are getting 940. When we add these, we are getting 32,170. So that information is enough for us to get all what we want. Okay, so let's get the mean. So we need the mean first before we get the standard deviation. So we have the formula for the mean. Sum of fx over sum of f. Sum of f is 30. 30, adding the frequencies. That's where we got our 30. So we have our mean, x bar, is equal to 940 over 30, which is giving us 94 over 3, which is giving us a decimal 31.333. So it simply says 31.3 bar. So 31.3 bar is basically our mean. 31.3 bar is basically our mean. We have backed this one because this one is a recurring number. It keeps on coming back. So finally we have the mean. Now we could easily use the mean to get the standard deviation. We have the formula for the standard deviation, so we use it to get the standard deviation. So we are taught SD is equal to, the formula is there, so we simply now substitute in the formula. We have fx squared, the sum, which is this one. So we write here 32,170. 32,170 over, we have 30 here. Then minus the mean, we have 31.3 square. So we have started now working out the equation now for the standard deviation. So we come here, we continue from here. We say this implies that our SG will be given by, when we divide this, we say 31,170 divided by 30, we are getting 1072.3 bar again. 10.3 bar again. Minus, when we square this one again, we are getting 981.7 bar. Okay, all this in the root. All that in the root. So if we say 13 to this one, we are getting this one. If we square this one, we are getting this one. And we say our SD is given by, when we subtract this one, we are going to get 90.5 bar. The 5 keeps on repeating, so we are just saying 90.5 bar. Okay, so finally, when we get the square root of this, our SD is 9.52 to 2 decimal places. So finally, that is our SD. So this is basically how we get the SD for grouped data. Special attention has to be paid to interpreting the set builder notation. There are some cases where here we have less or equal to, meaning that this lower limit